Hello dear colleagues. In the previous lesson, we laid the technical foundation, examined what data are, what their life cycle is, and how we prepare them for models. We internalized a key principle, garbage in, garbage out. In this lesson, we will expand our understanding of data. We will begin with the most sensitive topic, personal data and their special categories which require special control. Then we will examine how artificial intelligence creates new, non-obvious risks, such as hidden discrimination. We will study new types of data, synthetic and augmented. And in conclusion, we will move from the question, what to the questions, who and how, and talk about roles in data governance. And at the end, we will traditionally conduct a small bonus test to check the knowledge from this lesson. If you are interested in the topic of AI governance, please like the video and subscribe to the channel. In this way you will help other people learn more about the topic of AI governance. Now let's begin. In the last lesson, we classified data by their structure. Now let's look at them through the lens of privacy. Personal data are any information relating to an identifiable natural person. The key word here is identifiable. Identification can be direct, when we have a name, a passport number, an email address or a home address. But it can also be indirect, when a set of seemingly anonymous data makes it possible, with high accuracy, to single out one person from a group. In the age of artificial intelligence, the situation becomes many times more complex. AI systems are capable of finding correlations inaccessible to human perception. This means that practically any behavioral data can become personal. An algorithm can identify you by your typing style, by the unique features of your gait captured by a camera, or even by how you move a mouse cursor. Therefore, in the context of AI governance, we must proceed from the assumption that many of the data we work with are, or can become personal. But not all personal data are equally sensitive. The European GDPR and similar laws single out a special category, special categories of personal data. This is information about racial or ethnic origin, political opinions, religious or philosophical beliefs, trade union membership, genetic and biometric data, data concerning health and sex life. For AI systems this creates special challenges. Let's take a credit scoring system. It does not directly use information about a borrower's race, that is prohibited by law. But an algorithm can indirectly discriminate on the basis of race by analyzing the postal code where a person lives, their education, or even the shopping list at a supermarket. This phenomenon is called proxy discrimination, discrimination through indirect features. The algorithm finds statistical regularities between seemingly neutral features and protected characteristics and uses them to make decisions. Formally, the law is not violated, but the result is the same, systemic discrimination. Biometric data deserve special attention, unique physiological or behavioral characteristics of a person, fingerprints, retina, facial geometry, voice, handwriting, gait. With the development of AI, biometrics have ceased to be just a method of identification. Modern algorithms can extract from biometric data information that a person never intended to disclose. From a face photograph, an algorithm can already attempt to determine sexual orientation, political views, even a predisposition to certain diseases. This creates a fundamental consent problem. When a person gives consent to the use of their photograph for face recognition in a security system, do they give consent to the analysis of their psychological profile? Obviously not. But technically the same data can be used for both purposes. In the previous lesson, we talked about problems of data quality and data scarcity. Modern artificial intelligence offers elegant solutions that simultaneously help to cope with privacy risks. These solutions include synthetic data and data augmentation. Let's move on to data that did not exist in nature at all before the era of artificial intelligence, to synthetic data. These are artificially created data that imitate the statistical properties of real data but do not contain factual information about real people or events. Imagine that you need to train a medical diagnostics model, but the use of real patient medical data is associated with strict confidentiality constraints. Generative models can create thousands of synthetic medical records that are statistically indistinguishable from real ones but are not linked to any real patient. Or let's take autonomous vehicles. Training algorithms requires millions of road traffic scenarios, including rare and dangerous situations. Synthetic data make it possible to create virtual scenarios that in real life occur extremely rarely or are simply too dangerous for data collection. Synthetic data solve several fundamental problems at once. First, the problem of confidentiality. Second, the problem of imbalanced datasets. In real data, rare events are poorly represented, while synthetic data allow the creation of a perfectly balanced sample. Third, the scaling problem. Creating synthetic data is often cheaper and faster than collecting and processing real data. A related but still separate approach is data augmentation. If synthetic data are created from scratch, then augmented data are modifications of existing real data. In computer vision, this can be rotating an image by a few degrees, changing brightness or contrast, adding noise. One photograph of a cat turns into dozens of variants, the cat under different lighting, from different angles, with various distortions. For the model, these are different examples, although the source image is the same. In natural language processing, augmentation can include replacing words with synonyms, changing the order of sentences, paraphrasing text. One customer review can generate several variants with the same meaning but with different wording. Augmentation helps models become more robust to variations in input data and perform better in real-world conditions, where data are never perfectly clean. Now let's talk about what often remains invisible but is absolutely critical for data management: metadata. If data are books in a library, then metadata are the catalog cards that tell us about these books. Metadata are data about data. They describe what each data element means, how it was created, who has access rights, when it was last updated, and in what format it is stored. In the context of AI systems, high-quality metadata solve numerous practical tasks. Imagine a dataset with 1 million records about bank clients. Without metadata, status field with values 1, 2 or 3 remains a mystery. Metadata explain: 1. Active client, 2. Temporarily blocked, 3. Closed at the client's initiative. But metadata are not only technical documentation. They carry information about data provenance, their quality, and usage restrictions. For personal data, metadata should include information about user consent, processing purposes, and retention periods. In the previous lesson, we discussed data provenance and lineage, the path of data within the system. But where does this path begin? Understanding the data source is the key to assessing their reliability and the lawfulness of their use. Sources can be classified along 2 axes. The first division is internal versus external sources. Internal data are information that an organization generates and controls independently. For an online store, this is customers' purchase history, the product catalog, website visit logs. For a bank, client transactions, credit history, ATM data. The advantages of internal data are obvious: full control over quality, format, and refresh frequency. You know how these data were collected and can influence the process of their generation. This simplifies compliance with security and confidentiality requirements. But internal data are often insufficient. A recommender system of an online store may need data about trends on social networks, economic indicators, information about competitors. Here external data sources are necessary. External sources are data from third parties, open government data, commercial data providers, partner organizations, public social media APIs. The use of external data opens new opportunities but creates additional risks. You do not control the quality and availability of these data, legal restrictions on use may arise. The second important division is primary versus secondary sources. Primary data are collected directly for a specific purpose. If a bank conducts a customer service survey to improve customer service, these data are primary for this task. Secondary data were initially collected for other purposes but are used in a new context. The same survey data can be secondarily used to train a sentiment analysis model or to predict customer churn. Understanding this difference is critically important for assessing data quality and applicability. Primary data usually reflect the target task more precisely, but their collection requires more time and resources. Secondary data are available immediately but may contain biases and be not fully relevant. We have already said that data quality, their management, their sources, and metadata add up to a single discipline called data governance. This is a system of policies, procedures, standards, and technologies for managing data as a strategic asset of the company. Data governance is not a one-off project but a continuous operational process. One can imagine that an organization without such a process is like a city without traffic rules. Everyone drives as they want, accidents are inevitable, efficiency is close to zero. Therefore, a clear allocation of responsibility plays a key role in data governance. Let's consider three main roles. The data owner is, as a rule, the head of a business unit who bears responsibility for the strategic value and the risks associated with a specific data domain. They answer the question, what are we doing with these data and why? The data steward is an operational role that is responsible for daily management of quality, metadata, and compliance with rules. They answer the question, how high quality and fit for use are our data? The data custodian is a technical role, responsible for secure storage, backup, and transmission of data. They answer the question, where and how are our data stored securely? A clear definition of these roles is the foundation of accountability in any AI project. Friends, here are 6 small questions on the topic of today's lesson. Pause the video and try to answer them. And if any questions or points of this lesson caused you difficulties, do not hesitate and ask us in the comments. We will definitely respond. To sum up, in 2 lessons we have traveled from technical basics to organizational accountability. We have understood that managing data in AI is not only creating and editing tables. It is also protecting people, avoiding systemic discrimination, and clearly distributing responsibility. But for all the necessity of theoretical knowledge, we insist on the critical importance of applying such knowledge in practice. And therefore, in the next lesson we will move on to absolutely practical work. We will learn to analyze and document information about working with data in concrete practical cases, and will continue to fill our key practical instrument, the AI System Passport. That's all for today. See you in the next lesson.